The Heston Nandi Garch model was introduced by Heston Nandi in 2000, and it combines features from both the Heston model of stochastic volatility and the Garch generalized autoregressive conditional heteroscedasticity model. On YouTube, I've seen a lot of people mention the Heston model, which is largely outdated by the Heston Nandi model. What it tells me is that not many people try to apply these things. They teach it in a theoretical academic format. My channel is all about practical application, although it may seem strange at times, but there is a purpose and a use behind what I show. Anyway, to clarify, the Heston Nandi Garch model is a closed form solution for pricing European options when the asset return dynamics follow a Garch process. This model extends the classic Black-Scholes pricing formula to a more realistic setting where volatility changes over time and is predictable from past information. The Heston model is a stochastic volatility model that assumes continuous time processes. The Heston Nandi Garch model operates in discrete time. It's essentially a Garch model with a closed-form solution for option pricing. The model recognises that asset returns and their volatility are predictable based on historical data. As you can well imagine, the option prices, the volatility behind option prices tends to mean regress. That is how many traders like me make their money, out of using implied volatility, being on the right side of implied volatility to set their trades and hoping that it will mean regress. Depending on where you choose to trade, approximately between 1 and 2 standard deviations, it will yield a profit. So between 70 and 80% of the time, maybe up to 90% of the time, approximately, probabilistically speaking, you will profit. But it's not as simple as that. There is a lot involved. Anyway, the model uses the concept of Garch, which models volatility as dependent on past squared returns and past variances. It assumes that traders from their expectations of future volatility based on these past observations. The Heston Nandi Garch model adds an additional component to capture the risk premium associated with this predictable change in volatility. One of the key advantages of the Heston Nandi Garch model is that it's specified in a way that allows for a closed-form European option pricing formula. This is quite convenient as it avoids the need for complex numerical methods that are often required in other Garch-type option pricing models. The Heston Nandi Garch model is particularly useful for traders who rely on historical data to inform their trading strategies. It's used for pricing and hedging European options when the underlying asset returns exhibit time-varying volatility that can be captured by a Garch process. Mostly for traders like me who trade on the secondary market, I'm not a market maker, I'm a reinsurer, what I call myself. I am an option rider, but I have to take prices from the market maker or from the market generally. So I'm not a price setter like a market maker. Now, this is actually really, the Heston Nandi model is really only good for people who want an equilibrium, frictionless estimate of the price. It doesn't give an accurate market reflection. It's a close, but it's sort of an equilibrium price. So it's good for market makers as a standard, and it's also good for people trading a long way out to give an idea of the possible evolution of price. Even though the price is instantaneous, it's given a historical approach from the volatility profile. It gets less useful once you get less than 30 days and less than 20 days. It doesn't quite have a big enough range behind it to really satisfy the pricing approach of the model. Anyway, back to the point. Like all models, it has its assumptions and limitations. For example, it assumes that the risk premium is constant over time, which may or may not always be the case in reality. Well, as we've seen with the constant fluctuation of interest rates, with the rise in inflation in late 2022 and 23, this is not actually a good assumption. But generally, before that, interest rates did not move much for many years, so it's not too bad a departure from. It's not a bad flaw. Anyway, the Heston Nandi model, we're going to look at it in R, and we're going to investigate it further, and I'm going to bring in an Excel version as well. It's from an old book, well, not old book, it's from about 2003 to 2007, and it's written in VBA, and it really is a testament to those option quants' skill at programming. They managed to get such a complex equation so easily done in VBA. Well, I don't think they did it easily, but they mastered it. The R code is also quite finicky, but it's a more robust programming language than VBA, so it's not quite such a remarkable achievement. But still, it's a difficult model and it's difficult to implement. It took me a long time, and I've already written a video about this where I was equivocal about the Heston Nandi model. I still personally wouldn't use it very much, or hardly ever, but it has uses for some people. So I'm going to revisit it and revise my opinions from the past. Okay, we'll start looking at the model in a minute soon. Here we have a, I loaded the my R code into my datacamp workspace. I'm also going to run it in RStudio and a Python from datacamp workspace. And the problem I've mentioned before about this package, I know actually I wrote it in a Stack Overflow letter comment. I'm tired, sorry. That's why I'm doing this instead of running it in RStudio. You need to install fOptions from, you need to load DevTools, and you need to install it from GitHub, create fOptions, because fOptions, the RMetrics team stuff's still up there, it's still maintained, but fOptions, it's not often maintained, generally just bits here and there. Someone appropriated it for misuse, I believe for financial gain, which is against the open source CRAN R library rules. So it was deprecated, and if you want to, you have to go to RMetrics team's GitHub site and load it manually from GitHub. It's not on the CRAN repository. Anyway, that's the instructions you need to do that there. Anyway, you can see I've loaded all the libraries, and this is a simulation model, not the one that I've actually run in RStudio, which took quite a lot. Yeah, that was from actual real data. This is taken from a simulation. So as you can see, it's got the same basic parameters to start with, and we estimate a sim, and we get a plot of the sim, then we fit the sim model, then we print out the charts and the stats, and let's see what we got here, the results. Heston Nandi Garch parameter estimation, Heston x equals ts model symmetric true, that's the lambda, omega, alpha, beta, gamma, and risk free was not. Coefficient that was fitted, that's the change fitted model,
log likelihood, persistence and variance. Today. Oh. And Garch parameter estimation. Same again. Mean, variance, skewness, kurtosis, persistence, mean sigma, mean sigma, mean sigma, mean sigma. And there's a chart of HN Garch symmetric model, which compares to the actual one I run, which has these charts as well. I'm doing this after I did that, so I'll edit it in, and you can compare. Maybe I might compare it if I've got time. I want to get this done. And doesn't look. You can't really expand the charts in a datacamp thing like you can in RStudio, but you can see that's the conditional standard deviations, which is similar to the chart I had in RStudio, and that's the log returns. So that's a HN. That's a Heston Nandi simulated Garch fit, which can be good for speeding up the solution to data, rather than having to estimate from historical data, which takes a while. Although I've got a pretty powerful processor, so it's not bad. But if you had an i5 or a lower AMD processor, it would take a while, 15 minutes maybe half an hour. I've got the top of the range 2 years ago now, or 1 year ago now, i7, which has been superseded, and there's an i9, but I believe now, or that might only be for mainframes. And there's some pretty powerful AMD ones too. I don't deal with Macs and Linux compatible chips and ARM chips and things, so I don't know about those. But yeah, it doesn't take too long to estimate on mine. Anyway, I'll just move over to the Python code. So I'll stop this. Here's my, I got this off the net. It's not original code. I think I got it from Medium. One of those coders put it on there, I think. I should give credit where credit's due. I'm sorry, I apologise there. If he comes across this and sees me, I'll write it in the link below the video. I'm not a Python programmer as such. I have to use on ChatGPT. I've written Python code, but not for finance. I never really got into it for data science much. I used to use it just as a generalized programming language, like you would use Visual Basic as opposed to Visual Basic in Excel. But anyway, it's not too hard to use if I spent the time, but for me is so much easier. It's so much more in line with what I learnt going back to the 80s. C and then time series library program and all those sorts of things back in those days. It's much more similar to those than Python. Python's it's really unique in that it's a lot like Visual Basic, but even more simple. Yeah, it is a good language. Anyway, here's the parameters. I tried to make it as close as I could to my example on the RStudio segment.
That's what I left out of the last explanation of the simulated
3.5% from my datacamp. I didn't actually estimate the price. Oh well. I'll leave that as an exercise for you to cut and paste this section and exercise the price. Find the price, sorry. The actual price was $220. The actual price of the put was $195. I wrote that down. Let's see. Have I got the daily? Well, the model actually calculated the volatility there, whereas you put the volatility in this Python code, so I'm not sure how that works. Time in days is 129. That's probably important. It doesn't seem to have an interest rate. Where's the interest rate? The daily price. No, it doesn't have a rate. It's got a rate of 0. whereas here has a definite rate, so it's definitely going to differ because of that. Alright, I'll go back and find it. There. I've got a rate of 0.35, which is approximately what it is in US. I don't know, I just left that. I'm not sure whether GDX dividends are 0.1%. We should just take that out, I think, if we don't know. Just put naught. V kappa theta sigma rho. Where's the time? Let's see. Where is time? I don't think tau is time. Generally not in any other model. Tau is its own. No, it's not tau. It doesn't appear that time takes... Seems odd. Time's not a factor. It's a very... I honestly can't work out this code, but it's there for someone else to use. I'll have to see if I can locate the article. I'll probably have saved it in my OneNote or somewhere, LockSec or somewhere. I'll have to look up how it works. Sorry, I'm raving on, but I'll run it. And we got a price of a call of 287. Well, it's there. Contact me on buymeacoffee.com if you want the code, or it's on here. If I don't know if it's, I think it is publicly accessible. It's also out there somewhere on Medium or one of those data science sites. Anyway, bye. Okay, we're going to start looking at the actual code where I empirically run from the actual downloaded data of GDX. It's in notebook format. I don't think I'll run it again, but I'll go through the results. Load fOptions, load quantmod, use get symbols command to download the data for GDX. We run a string to get a structure to get the structure of GDX, which is down here, time series object, etc. We add a variable GDX return, which takes the daily return of GDX type log. We want logarithmic returns. Generally in finance you always want logarithmic returns. Lots of people make the mistake of using arithmetic returns. It's really not good for quant maths. Anyway, GDX as time series GDX, it's going to be turned into a time series for R metrics. R metrics time series data has to be converted into its own unique time series format, and it's called time with a large S series, and we convert the data there. Okay, and then I turn the GDX time series return data from GDX return into a time series. Sigma daily. What have we got down here? Not much. The daily sigma is 2.6%. Okay. Simulate the Heston Nandi Garch 1.1 process symmetric model parameters. It's really difficult. These are just starting parameters. It'll be estimated when the maximum likelihood method recalculates, but the opening parameters are critical. I just take the standard ones from our metrics team's document, which outlines how to use our metrics stuff. I have tried to use my own parameters, and it's very sensitive. You're better off sticking with theirs. And the time series GDX return, and we print a chart, and then we fit the maximum likelihood with a Garch fit model, similar to when we did with the HN sim model. We fitted a Garch fit model with maximum likelihood, And here is the chart. We just enlarge it. That's the fit, the call Heston Garch fit. The parameters when they're re-estimate, that's original, and that's the coefficients after its re-estimation. Log likelihood, persistence, gamma. So it's quite different to the simulated model I had on my datacamp. And the chart's a bit different too. We'll just shut that. And diagnostic analysis, we're going to print the charts. Let's see what we get here. That is the log returns before the application of the statistics, and that's conditional standard deviations after the fit. You can see that's the 2020 crash, standard deviation, volatility absolutely surged, and that's the GFC surge in volatility. Once again estimated in the downward pressure on the returns. And we'll go down. Heston Garch stats. This is what we showed in the datacamp worksheet. Ketosis, skewness, variance, mean. These are daily means, so you have to times them by 252, square root of 252, to get the actual yearly results. Leverage, means of all the different estimates. And there's the model with the new data. That's the price at that time. It was about a week ago. My exercise price was 29. The stock was at 29.15, so it was already in the money, which was not good. But I sold it out. The time in. Oh no, this was an example one I took. My trade was okay. I took one a year out, 129 days out, because Heston Nandi Garch model is supposed to work better for long period options, not so good for close period options. So I run that, and the model fits the beta and the model data frame there to collect it all. And that is a HNG option feature which estimates. That's all the estimation stuff. And the call price was actually 220 that day, and the put price was 195, and the volatility was 34%. The Heston Nandi model estimated 165. The Black Skulls estimated 365. There's a big difference between them, and the actual price was midway between them both. And the put was Heston Nandi was 121, and it was actually 195. Black Skulls was way out, and there's a big difference. Okay, percentage difference in price. Excel model. And yeah, that's basically it. So we'll move on, and I'll see if I can drag out the Excel model. Spot price 29.15. You can see strike price 29. Risk-free rate. Well, we'll better change that. That's not right. Oh, something went there where I've noticed the risk-free rate. The R-metrics team just leaves it off. It tends to make things go like the Heston Nandi price went crazy. It doesn't handle interest rates, as I mentioned earlier well before. Now we'll see what happens now. It's a bit better, still not that accurate. Time maturity 129 days. Lambda. Current Garch variance 0.15. Alright, we'll change that to I think it was I should check. I'm not exactly sure. I'm pretty sure it was 30%. It's calculating again. It's a bit better, yeah, it's a bit more accurate. Yep. Okay, so this one estimates a price which is pretty similar to the R-Metrics one, a bit less even, $1.72. It's got a pretty good delta, it's got a good gamma, it's good Vega, it's good programming. Yeah, so it is possible to do these things in Excel.
Quite well.
Most people would now just use the add. You can do it in Excel. Most people would just call Python. Python's not available yet. It's being rolled out around the world in the Office 365 version. I can get a version. I had the beta version. Anyway, I'll sign off. Thanks. Bye.